Good morning. Welcome to our first lesson in Math 1101. Topic number 1 is called complex numbers. It's a different kind of number than you may have been used to seeing before. You may recall back in Math 1700 when you learned how to solve quadratic equations, there were certain situations where you ended up with the square root of a negative number. Now, you may have been calling that I, which is what we define the imaginary number as, the imaginary unit, or perhaps in Math 1700 you may have just been calling this a solution, not a real number, and leaving it at that. Well, we're going to learn in this course that the square root of a negative number is an actual number, and we really do calculations with that. What we do is we define the square root of -1 by the symbol J. So you're going to be seeing expressions now. You're going to be seeing terms that contain J. And wherever you see that, you understand that it stands for the square root of -1. Now, most textbooks, by the way, do not use the symbol J. And in fact, calculators don't use the symbol J either. Most textbooks will actually use the symbol I. If you look carefully at your calculator, you may see a button that has the symbol I just above it. I think that's what you would see on the Casios or the Texas Instruments. So have a look for that, and if you see that symbol on your calculator, then you can use your calculator with these terms. These are called imaginary numbers, by the way. All right, anything that contains J is said to be imaginary. Let's look at example number 1 here on page 2. How do we simplify expressions involving square roots of negative numbers? Well, you did learn how to simplify radicals back in Math 1700. What I suggest is you look at the number and you find the largest perfect square that actually goes into the radicand, which is the number in under the principal square root sign, and that's how you simplify it. The square root of -16, for example, break that apart into the square root of -1. Always do that if you're simplifying the square root of a negative number. And then, of course, the other number would be the square root of +16. Now, we know what the square root of 16 is. That's just 4. And this symbol here now, the square root of -1, remember we define that to be the symbol J. So there, 4J is the square root of -16 simplified. Part B, we have a peculiar case here. You're taking the square root of some number, and then you're squaring the result. Well, if you're doing it in that order, if you're always taking the square root first and then squaring it, it turns out that the square root symbol and the squared symbol cancel each other out. So the result here is just -8. Now that's different from if you were squaring first. So, for example, if you have -8 squared first and all of that isn't under a square root symbol, this is a different creature altogether, because what you're supposed to do here first is square the -8. And of course, that leaves +64. And now the square root of +64, the principal square root, is +8. So note the difference there, everyone. Note that one will give you -8 and the other result will give you +8. Be very careful with those types. Part C, we have the square root of -12. Again, I'll break that apart into the square root of -1. That's my J. And then if I look at 12, the number 12, the largest perfect square that will go into 12 is actually 4. So I'll break this apart into the square root of 4. And what would you multiply 4 by to get 12? Well, that would give you the square root of 3. So this is your J. That's your imaginary unit. The square root of 4 is just 2. And the square root of 3, of course, you leave that as is. So your total result becomes J multiplied by 2, which is 2J, multiplied by the square root of 3. Note that J is usually written in front of a radical term, not behind. Okay? So the ones down and under that now on page 2, these practice ones, you try these. You may not have your textbooks just yet, but you should be getting them soon. But you can just copy them down here on a blank piece of paper if you don't have your textbook and try these. Solutions will be posted to D2L very, very, very shortly. Okay, page 3. Now here's where we get into powers of J. You're going to see in the future expressions involving j squared, j cubed, j to any power, really. And you have to simplify those down to their simplest form. J to the power of 1, well, that's just j. If you see j, you leave it as j. J squared, however, remember, now that's j multiplied by j. So that would actually be the square root of -1. That's what j is, squared. And this is an expression similar to what we just saw on the previous page. When you take the square root of a number first and then square it, they cancel out. J squared equals -1. So anytime you see an expression involving j squared, you change that into -1. J to the power of 3, we can think of that as j squared multiplied by j. J squared we just saw is -1 multiplied by j. So j to the power of 3 is actually -j. And we would have to change j to the 3 into that term. Now j to the 4 is interesting, because if you think of that as j squared multiplied by j squared, that would be -1 multiplied by -1 again, and the result is +1. So j to the 4 is 1. Well, not just j to the 4. J to the 8 is also 1. J to the 12 is 1. J to any power where the expression is a multiple of 4, like for example, j to the power of 40, because 4 goes into 40, then we can just immediately write that as a 1. J to the 5, break this apart into j to the 4 multiplied by j. J to the 4, remember, is 1 multiplied by j. So the result, j to the 5 is equal to j. So that's your strategy, everyone. That's how you can simplify powers of j. Try to extract as many powers of 4 as you can, as many j to the 4s as you can, and whatever is left over, that's what you would write the expression as. Really, the only ones you need to remember is j squared is -1, and j cubed is -j. Really, that's the only ones to remember. So let's look at some expressions down below here now. Practice number 2. In each of the following, simplify to express with the lowest exponent. So j to the power of 51. Well, we cannot leave j to the power of 51 as is. But 4 is not, or 4 doesn't go into 51. 51 is not a multiple of 4. So what you try to remember or try to think of is what power of j, just a little bit less than 51, is a multiple of 4. Well, 50 won't work, 49 won't work. J to the 48 is what you should break this apart into at first. So j to the 48, remember, that's going to become a 1 because 4 goes into 48. And what's left over is j to the power of 3. So this really becomes 1 multiplied by j to the power of 3, remember, is -j. So it turns out that j to the power of 51 is -j. And that's what you would have to write it as. J to the 26. Well, let me think. 4 does not go into 26. 4 doesn't go into 25, but it will go into 24. So break this apart into j to the 24 multiplied by what's left over, which in our case is j squared. So j to the 24, remember, that's a 1, multiplied by j squared is a -1. So j to the 26 becomes -1 itself. A couple of expressions down below. All right, let's try these. We have 3 times j to the 9 plus 12 times j to the 11 minus 7 times j to the 18. So what we do here is one piece at a time, we simplify the powers of j. J to the 9. 4 will not go into 9, but it will go into 8. So break this apart into j to the 8 multiplied by j. And then there's a plus sign. 12. J to the 11. Well, 4 won't go into 11, but it will go into 8. 8 is the smallest multiple of 4 less than 11. And j to the 3 is what's left over. Subtract 7. J to the 18. We'll break that apart into j to the 16 times j squared. Now remember, j to the 8 is a 1. J to the 8 there is a 1. J to the 16 there is a 1. So what you're really doing is you're multiplying here by 1s. The first expression just becomes 3j And then we have plus 12 times j cubed, which is negative j. Subtract 7. J squared, remember, is negative 1. So what we end up with here is 3j minus 12j plus 7. Now, you can combine the j parts, but you cannot add the 7 onto these. You add and subtract these terms the same way you would for polynomials if they were x's. They have to be like terms to add or subtract. So you can just write this as 7, that's the real part, minus 9j. Now, you cannot combine those two terms, 7 minus 9j. You would have to leave it just like that. Notice that here you have a real part. 7 is a real number. Negative 9 is our imaginary part. Now, we're going to see in just a little while that any number that's composed of two pieces like this, well, first of all, it's a complex number. Yes, every number you've ever seen is a complex number. But this is what we call a complex number in a certain particular form, rectangular form. So what we'll do now is we'll look at D. I'll just erase some of this. And we'll do D, and then I'll let you try some practice ones after that. Okay, so let's just erase all of this. Now, let's have a look at the last one there. And I noticed that the first thing it does, it starts out with negative 2j to the power of 100. Well, what do you know? 100 actually is a multiple of 4. So this just turns into automatically negative 2 times 1 plus 5j. Now 127 is not a multiple of 4. 126 is not, and neither is 125, but I think 124 will be multiplied by j to the power of 3 minus. Now this next expression here, you'll notice you have to use your power of a power rule. 4 squared becomes 16, and j to the 13 squared becomes j to the power of 26. So in our next step, we have negative 2 times 1, which is just negative 2. J to the 124, remember, that's 1. So it's become plus 5 times 1. J cubed is negative j minus 16. Now, what to do with j to the 26? Well, let's break that apart into j to the 24 times j squared. Now, remember, j to the 24 is 1. So we're left with negative 2. 5 times 1 times negative j minus 5j. And then we have negative 16 times 1 times j squared. And j squared, remember, is negative 1. You always replace that. So what you're really left with now, this becomes 16 minus 2. That's 14 minus 5j. You can't combine those two terms right there. So this is your result. Again, notice it's composed of a real part and an imaginary part. So this is a complex number. You can't combine those terms. You have to leave it just like that. And so basically, everyone, that's how we simplify powers of j and how we simplify terms containing negative square roots. So I'll stop it for this video. What we will do is in the next in the next video, we're actually going to start section 1.15, which is solving linear equations involving complex numbers. So have a look at these. Please try the practice examples that we did not do, and see how you get on with those. Okay, so I'll finish this video here. Bye-bye for now.